This video is going to be about confirmatory factor analysis, and there is a lot to do in a confirmatory factor analysis, so we'll be lucky if we finish, but let's try anyway. Alright, first we need to obtain a roughly decent model quickly. So the quickest way to do this is to grab that pattern matrix we finalized, just right click, copy, and go over to AMOS. Start up a new model, make sure your data is in there. Double click that, go get my data, hit OK. Go to plugins, and if you don't have this plugin, Pattern Matrix Model Builder, you need it. You can go to my YouTube videos and look for AMOS plugin. It's an EFA to CFA pattern matrix builder. You desperately need this. Go get it. Then you paste your pattern matrix in there. Create diagram. It's going to think for a minute. A long minute, I suppose. Wait for it. Haha, there it is. Isn't that beautiful? Ah, thing of beauty. Alright, let me name each of these. Sorry, that's kind of small. So this is useful. This is joy. This is play. This is atypical, use. Decision quality. Comp use. I call it comp latent because it's we captured it with a latent bunch of items to form a latent factor. Info ac. Okay. That's great. And now let's just set some output properties. I would like standardized estimates and modification indices. I'd really not like to look at any modification indices less than 20 to start. You know, simplify my life a little bit. Go ahead and save that. Where shall I save it? Let's go to recent places, StatWiki. There we go. Maybe create a new folder called AMOS. Okay. And this is CFA initial. I highly recommend saving multiple CFA models. Save and run and hope it runs. Yes, it ran. And we can just eyeball it if we like. Go up here. Those look really good. Those look really good. Why do they look good? Because they're over 0.7 on average. The lowest one here is 0.63, but that's fine. 0.81 is the lowest. 0.77 is the lowest. 0.70. Wow, these look really good. Now I want to look at these covariances. Anything above 0.8 is a little alarming. This is 0.72. That's pretty high, but we knew that was coming. That's decision quality to info quality. And all the rest are pretty reasonable. So let's go look at our output and go look at model fit. This should be between what, 1 and 3, so that's great. This should be above 0.95, so not fantastic. And this should be not significant, so that's good. And this should be less than 0.06 at the liberal threshold. 0.05 is the more conservative threshold. Modification indices. All right, so we have some big fatties here. I'm going to start with the biggest, E8, E13. Go look at that. E8, where art thou? E8 and E13, they are on the same factor, joy. So I'm going to go ahead and covary those. E8, E13. And let's do a couple others while we're at it. 15 and 16. These two. Next biggest one here is this 1 and 2. And let's see where that takes us. We run it, it runs, which is great. We look at output, we look at modification indices. We have a couple left, 29 and 30, 28 and 30, and then 6 and 7. Let's do 6 and 7 first. 29 and 30, and 28 and 30. There we go. We run that. It runs, hallelujah. Look at the modification indices. There should be none. Good. Because we set the threshold to, what, 20? So there'll still be some. They're just lower than 20 right now. We go to model fit. We have achieved a good CFI, which is great. Still good on C min over DF. And we're fine for RMSEA. So I'm going to say this is a good initial model. It's rough, it's good, it works. So, oops, check on that. Doing variance test. Yikes. Okay, so the next thing we need to do is do our invariance test. Why do that first? Well, because if you find some stuff in your invariance test that requires you to remove items, then you've got to redo everything. Let's say you did it out of order. You did your common method bias first, or you did your common method bias before you did your invariance test. Well then, if you change things during your invariance test, you've got to redo your common method bias. Or if you refined your model before you did invariance test, but then you remove things during the invariance test, then you've got to, again, redo everything else. So do your invariance test first after you get a rough, good working model. To do the invariance test, you double-click group number 1. I'm going to make EXP, that's for experience, low. EXP high. Frequency low. And frequency high. And then go add the data to those. Recent places, StatWiki, there you are. There it is. And then go add a grouping variable for exp low. It's going to be experience, obviously. Exp cat, okay. Oh, sorry, grouping variable. Exp cat. And the grouping variable is going to be freak cat. And for this one, again, freak cat. All right, and then a grouping value for the top one is 1. For the second one, it's 2. Sorry, I go really fast, but it's in a YouTube video, so you can slow me down and pause me and rewind me, or the video at least. Excellent, and you can see the sample size for each of those groups. They're fairly even, which is great. And now I'm going to, ooh, I should have saved this earlier. Oh well, file save as, CFA, invariance. There we go. Save. You know what? I'll just add another group here, and new. Sorry. Just do all, and I'll give it all the data, and then we'll have an initial with our group. There we go, and that has all 380. Okay, save. Now what do we want to do? We want to run it. Oh, actually we want to get the critical ratios and then run it. So let's do that. Boy, that's a lot of work for this guy. Critical ratios for differences, right there. We don't need modification indices. And save and run. It's thinking. It's a lot of models. But it ran. That's great. All right. Now, we're not going to eyeball anything. We're just going to run right into it. Go to estimates, scalars. We want to go grab the stats tools package. There it is for me. Wherever you have it. If you don't have it, it's on the wiki. Go find it. We're going to go to the group differences tab. And we need to paste regression weights table in A2. So let's go do that. Regression weights table, here it is, for experience low. Make sure you click on that. Right click, copy, and paste. Now go get it for experience high. Copy and paste. Now, it says here, make sure there are no rows without labels. If so, then delete those rows, then click this button. Well, I have several rows without labels. All the ones that are constrained to be 1. You'll notice back here, see this Joy 7 is constrained to be 1. If I go find joy 7, here it is. It's constrained to be 1, so it doesn't have a parameter label. That's like par 6, par 5. I've got to get rid of that row. I'm going to get rid of that row, that row, that row. I'm just holding Control and clicking. Does his own theme music. There we go. And get rid of those. You can right-click and delete them if you like. Cool. And then I'm going to go get the critical ratios table, which is right here, and it's going to be enormous. Here it is. Right-click, copy. It's going to think about it because it is, like I said, a really fat table. Go back over here and paste it. And run and cross your fingers. Oh, it worked. That's amazing. I love it. All right. I'm just going to expand this so that I can get everything. Let's see, did it all fit? Oh, come on. There we go. And like this. Just being OCD, don't mind me. Okay, what this tells me is where we are different on which indicator paths. And we want to know, is there at least one indicator for each factor that is not significantly different between groups? So we'll look at factor usefulness. There's only one significantly different item. That means we're fine. If all of them were significantly different, we'd have a problem. Here's joy. Looks like we're good. The stars indicate significance. We have 2, 3, 4, or 1, 2, 3 that are not significant, so that's half of them are not significantly different. Here's playfulness. We're pretty good there. Here's decision. Oh, atypical use is good. Decision quality. Do I only have 3? Oh, yeah, right. That's good because there's only one that is significant. Comp latent. There's one that is not significant, thank goodness. And info quality. They're all not significant, so that's good. What if they were all significant? What would we do? Well, there are a few things you could do. You could see. You could. Oh, that's a tough one. Just a moment. Okay, I've thought about this, and two things you could do. First, look to see at what level they are significant. We're looking for 0.05, which is 2 stars in this case. If you have some that are significant, but they're at the 0.1 level, here it is, 1 star, that's fine. We want to look at 95% confidence. So let's say we had, here's comp latent, and let's say this one down here, this 1.49 was actually significant at the 0.1 level, 90% confidence. We'd say we're still okay because it's at 90% instead of 95%. So that's one thing. Hopefully you'll be all right with that. If not, well, then what you might need to do is go look for outliers on each of these items. Go back to the univariate outlier detection using box plots and find the outliers and remove them in order to remove those major differences. That would be probably the next best bet. All right, I hope that helped. Let's do this for the other groups. Let's see. Now we need to go grab the regression weights table for frequency low. Copy, paste, and frequency high. Copy. Get rid of those rows that are useless because they have no labels. They're not useless, they're actually detrimental. If you try to run this without removing these rows, currently my little macro is not robust enough to handle it, and it will just crash and it won't work. Okay, critical ratio is stable. Copy. Wait for it. There it is. And run. Excellent, it worked. And we'll look at useful, we're good. Joy, we're good. Playful, we're good, good, good. Atypical, we're good. Decision quality, and everything else, actually, we're good. Okay, so we are metrically invariant, which is fantastic. That's great. So we have passed our invariance test. Check. Where's that? Right there. Next, we need to refine the model. Actually, we don't, because we didn't have to change anything in the invariance test. So we can move straight to common method bias. Now, if you've watched my other videos and you've looked through the wiki, you know that there are multiple ways to do this. I am only going to show you one way, the common latent factor method, because most of you probably won't have captured a marker variable, a social desirability bias variable, so no point in showing you how to do that. If you want to see how to do that, watch my other videos. So here we go. Let's see, reset that, get this out of the way. Oh, the painful part. Here's what we'll do. First, let me save this. Now, file, save as, I'm just going to overwrite the initial because we didn't finish our initial. We didn't save it after making all the changes. And then I'm going to go and just get rid of all these groups. Delete. Boy, it's thinking about something. Delete. Oh, I hit close. Delete. 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 Close. So now I just have the all left. That's great. I'm going to move this all over a little bit. Boy, it is thinking about something. It is not happy right now. And move everything to the right. Unselect. Create a common latent factor, and I'm going to make it enormous. You'll see why in a moment. Double click it. Just call this my CLF, my common latent factor. And, you know, do I need to go like this? I think. And then I start doing this really painful thing. I actually have a good friend, Russ, who is maybe programming another plugin that will do this for us. That would be fabulous. Hurry up, Russ. We really appreciate your work. I am going to pause the video and do this off camera. Wow, that was a pain. Glad it's over. But here we are. Let me save as CFA, CMB, oops, MB. And let's run it and hope it works. Run. Yes, proceed. And it didn't run. Ooh, iteration limit reached. Let's go look at the output and find out why. Here it is. It just didn't reach an iteration, or it reached its iteration limit. Joy is throwing us off. Look at this. Joy has some negative values, some positive values. How bizarre is that? Is there anything else? No, it's just joy. And you can see the standard errors are also really weird. So look at this one. Joy 3 has the highest. Let's try moving the constraint. You would think this wouldn't do anything. It's just Amos magic here. I'm going to move this constraint off of Joy 7 and move it to Joy 3, which was the one with the highest standard error. Let's see if that works. Run it, proceed, and it ran. Look at that magic. Isn't that amazing? And all the time you spent on that. Okay, it ran beautifully, actually. Let's go look at the standardized regression weights. Here they are. Looks like Joy is still suffering a little bit. Why do I say that? Because there's some low loadings here. Everything else looks pretty good. What I'm going to do is I'm actually going to put it somewhere else. You see these really low loadings? Joy 5, Joy 6. I'm going to move it to Joy, let's say 5, because I think that was another one with a huge error on it. And see if that helps. And it sounds like I'm just playing with it, but I am. But it's just how it works. It's the algorithm. So what was it? Joy 5, 1, 2, 3, 4, 5. and run it. Last time we converged in 19 iterations. This one took 49, it didn't work. Let's go over to Joy 6 and see if that helps. Joy 6. And hopefully it'll work. Please work. Nope. All right, looks like Joy 3 it is. Unless I want to play around a little bit more. Let me do that off camera. All right, I tried a bunch of others, every other indicator actually, and looks like Joy 3 is the best bet. We just have some major differences. So, what does that mean? That the standardized regression weights are very different when we add the common latent factor. That means that there is perhaps some common method bias. What does that mean? Well, we need to retain the CLF as we move into the SEM. So we'll do that. How will we do that? Well, we just leave this here. That's all. Okay, let me save that. And we'll go over to the list here. Common method bias done. What do we say as we report it? We say, yes, we saw some evidence of common method bias in our Joy factor, but not in any of the others, it appears. So Joy was slightly affected by common method bias. So we retain the common latent factor, which means we have common method bias adjusted variables or values. Okay, last, optionally impute composites. So we could do one of two things from here. We could impute composites and just sort of collapse these latent factors into single computed averages, essentially, weighted averages based on the factor weights. Or we could keep all of this as it is and create a hybrid structural equation model with both a measurement model component, that is latent factors with their items, and structural component where we have regression lines going between factors. Let's do both. I'll go to Analyze, Data Imputation, Proceed with Analysis. Notice my common latent factor is still in here. So proceed with analysis. It's thinking, go to Impute, and it worked, and close. Great, so we now have a data set that has those composite imputed factors, or variables, I suppose. It's this one, _C. C is for, let's pretend it's for composites. Okay, now we're done with the CFA stuff. That actually wasn't as painful as I thought it was going to be. Thanks.